beam. That is part of module 2. So I'm going to share my screen. You have the notes on Google Classroom. These are the notes concerning what we're going to do. If you are given point loads only, you apply the law of moments just as you did in N2. But in N3, they are going to give you uniformly distributed loads as well. What do you do with the uniformly distributed load? You change it into a point load just to calculate the reactions. Then once it's a point load, you treat it as the N2 beam. How do you change the UDL to a point load? You take the magnitude of the UDL, you multiply it by the distance that the UDL covers, and then you place that answer at the center of that distance that the UDL was covering, because it has now become a force. Thereafter, you treat it as a normal point load. Okay, then let's look at this as a question. So this is the question from November 2017 question paper. A beam is given. They say calculate the magnitude of the reactions at supports B and E. Okay, so now we're gonna look at how do we do that calculation. Let me just switch on here. Go on this side. Let's make it bigger. So yeah, I've got the question as it was showing on that question paper. So as the notes were saying, the first thing we do, we change the UDLs into point loads. We first convert them to loads. So the first UDL we have there is 5 kilonewtons and it's covering 3 meters. So we're gonna say 5 times 3, it's gonna give us 15. Then that 15, we place it at the center. It's now 15 kilonewtons. So it's 1.5 this side and it's 1.5 that side, the center of these 3 meters. Then the next UDL is 5, covering 2 meters. We say 5 times 2 gives us 10. So that 10, we place it at the center of the distance that it was covering. So we have 1 meter this side and we have 1 meter that side. And then the next UDL is 8 kilonewtons covering 2 meters. So we will say 8 times 2, it will give us 16. Then we place that 16 kilonewtons at the center of that 2 meters, such that we have 1 meter this way, we have 1 meter that way. Okay. Then once we have them as point loads, we calculate moments just as we would have done at N2. So to calculate, I'm just gonna write it down here. To calculate reaction at E, we will take moments about B. About B, so B is here, okay? If we take moments about B, we will first look at the clockwise moments and then equate them to anti-clockwise moments. Clockwise, we have that 10. 10, how far is 10 from B? It's 1 meter. Then next force, we have 10. How far is 10 from B? Is 2 meters. The next force is that 10. How far is 10 from B? It's 5 meters. The next force we have is 16. How far is 16 from B? Is 2, 5, 6. It's 6 meters. Then we're done with clockwise. Anti-clockwise, we have E. How far is E from B? At 7 meters. Then the other force we have that will give us a clockwise moment is 15. How far is 15 from B? Is 1.5. Then we're gonna do the maths. Okay, let's do the maths. So we multiply and add out everything here and subtract that one and divide by 7. So let's see. It's 10 times 1 plus 10 times 2 plus 10 times 5 plus 16 times 6 minus 15 times 1.5 all that divided by 7. Hey, what did I do now? Let me just run it quickly. Plus 10 times 2, plus 10 times 5, plus 16 times 6, minus 15 times 1.5 equals to that answer. Divide that answer by 7 equals to 21.929 kilonewtons. Okay. And then to calculate E, we're going to take moments by B. To calculate B, we're going to take moments by E. If we take moments by E, again, sum of the clockwise moments are equal to sum of the anti-clockwise moments. So clockwise, if we are here by B, by E, only B will be clockwise. B times 7. Then anti-clockwise, we have 16. How far is 16 from E? It's 1. The next force is 10. How far is 10 from E? Is 2. The next force is this 10. How far is 10 from E? Is 5. The next force is this 10. How far is this 10 from E? It's 6. And then the last force is 15. How far is 15 from E? Is 2, 4, 5, 6, 7, 8.5. 8.5. Okay, so B is going to give us 16 times 1 plus 10 times 2 plus 10 times 5 plus 10 times 6 plus 15 times 8.5 equals to all that divided by 7. It gives us 39.071 kilonewtons. Okay, so that is how we calculate the reactions at support. So the key thing is, if they give you uniformly distributed loads, you change them to point loads. How do you do that? Take the magnitude of the UTL, multiply it by the distance it covers, place it at the center of that specific UTL. Yes, and that's all. Thank you.